Hey there, as promised, going through two of these problems from chapter 23. One will be from section 23C and the other from 23D. So this one starts us off in 23C. Excellent. So after using logarithmic laws to write in an appropriate form, differentiate with respect to x. So they give us this function, f of x equals ln of x cubed over 2 minus 3x squared. Okay, so there's two ways we can do this. We could do the long, icky way, or we can actually use that hint that they give us in the very beginning and make this into a not so long, not so icky process. But just so that we know how much time and energy they're saving us, no, we're not going to do the long and icky way, but we'll at least talk about what you would have to do if you decided to do the long and icky method. Okay? So, long and icky method. We've got ln of a function. So we know that we'd have to use our ln rule to find our derivative. But then notice that we have numerator, denominator. This is a rational function. So we'd have to use quotient rule as well. But wait, there's more. Notice that you have 2 minus 3x quantity squared. So that means you'd have to do chain rule as well. Oh my goodness. We don't want to have to do all that. So we're going to be smart and we're going to say, you know what? They're telling us right here a really great clue. They say that we should use our logarithmic laws, so that's the stuff that you probably learned last year, about rewriting this function in a more appropriate form. Well, we see that it is ln of essentially a numerator and a denominator, and that should look similar to that form of ln of a over b. And if you remember from section 23b, we learned that we can actually rewrite that into a subtraction problem. We like subtraction. Subtraction is nice. So let's switch pen colors here and go straight into it. Okay. So our first step is to rewrite this function so that we're dealing with subtraction instead of division, because division means quotient rule. Ugh. Right? So that means I'm going to have the ln of my numerator. In this case, that's the x cubed. And then I'm going to subtract it from the ln of the denominator. So that's ln of 2 minus 3x, and that's squared. And I can write it just like that. Okay? So now that I've rewritten this I can take the derivative of very easily. Yes, I'll still need to use quotient rule for this guy here, the second term, but that's okay. At least I don't have to battle with quotient rule as well. Okay, so let's go ahead and start taking derivatives. So my derivative of f with ln, we learned that it's just going to be simply your derivative over your original every single time. So you keep your original function in the denominator, put your derivative in the numerator, and that's going to give you your derivative when you're dealing with ln of something. Okay? Right? So in this case, I've got x cubed. So that means into the denominator goes the x cubed. Nicely done there. Derivative of x cubed, well, that's 3x squared. Done. That was much nicer than long and icky. Now for the second one, yeah, we've got a little bit more going on because I've got that squared, but that's okay. We know chain rule, so we'll use that, okay? So I'll at least set up my little fraction bar there. I'm going to do a little aside over here. So if you remember with chain rule, the way we would set that up is we talk about out, then our in, then we'd have our original, and we'd have our derivative. Okay? So our outer function, when it comes to this 2 minus 3x squared, it essentially looks like something squared. And when I take the derivative of something squared, I get 2 something. Easily enough. Then the inner part is at 2 minus 3x. And then from there I take the derivative and I get negative 3. So when I need to figure out what my derivative is, just take these, multiply across. I know this is probably a review, but just want to make sure we've got it. So that means we've got negative 3 times positive 2, so that gives us negative 6. And then for this box, we put that inner function. So that's 2 minus 3x. And that is the derivative that goes into our numerator. So I've got negative 6, 2 minus 3x in my numerator. That's my derivative. And then my original was 2 minus 3x squared. Great. So now let's see if we can do some cleaning up, because I see some items that can definitely cancel out. So I see this x squared and x cubed. Well, if I take an x squared from both the numerator and denominator, I have just simply an x in the denominator. So that means I'm looking at f of x equals 3 over x. Good. And then for this next part, I've got 2 minus 3x in the numerator. I have 2 minus 3x squared in the denominator. Well, take out one from each, like so. And then that leaves me with minus negative 6, which makes us positive. And then I've got 6 in my numerator, and I've got 2 minus 3x in my denominator. And at that point, we're done. So by using those logarithmic laws, we were able to find our derivative and not have to go through the process of quotient rule and then having to remember chain rule and all those different pieces where we could have gotten lost and made a mistake. Okay, so that is our answer, f prime of x. So the slope or the derivative of this function is 3 over x plus 6 over 2 minus 3x. Another little something to note, since it looks like I've got some little extra time in here, is that when we rewrote our f of x in this first line here, so the ln of x cubed minus ln of 2 minus 3x quantity squared, you may have said, wait a minute, I remember something of another rule, and that other rule looked like this. It said that if I have ln of a to the b, I can rewrite that by putting that exponent b out front, and I still have ln of a. And yes, that is true. We could have used that here. And if we would have taken, for example, this first term, that 3, put it out front, so we would have had 3 ln of x. And then for this ln of 2 minus 3x quantity squared, that 2 would have come straight out. In fact, if we did that, you would have effectively avoided chain rule. So we have 2 minus 3x. Okay? You go through that same process, you will find that you get the same exact derivative. So you'd have the 3, there's your 3. Derivative of ln of x is 1 over x. Well, there it is, 1 over x. Now you have your negative 2 here. So we had that kind of hiding off somewhere. But then we had 2 minus 3x. So that's in our denominator. And the derivative of 2 minus 3x is negative 3. Aha! Negative 3 times negative 2 gives us positive 6. So either way you decide to do it, you'll still get the same derivative, which is super good. And if you have any questions on this, you know my number. You can text me or call me. All right, talk to you later. Bye.